Okay, so we have water that's flowing into a tub at this rate of gallons per minute at some t minutes. So when t is 0, let's just take a look at this. The rate at which the water's flowing in, so let's pretend we've got like some pipe here, and there's some tub here, okay? And so the water, of course, is flowing in, okay? And the rate at which it's flowing in, okay, the rate of change of the volume. So the change in the volume with respect to time is equal to 3t plus 1 over t plus 1 squared. So for example, here's some t values, and then here's some rates of change of the volume with respect to time. So when t is 0, this becomes 0 plus 1 over 1, or 1 gallon per minute. Okay. And then when time is, let's say, 1, we get 3 plus 1 over 2 squared, or 3 plus 1/4, or 3.25 gallons per minute. And let's do when time is 2. Okay, so the rate of change of volume with respect to time is 3 times 2, which is 6, plus 1 over 9. So that's 6.11 repeating gallons per minute, it looks like. Okay, so now the question is, though, what is the volume? How much water is in the tub? What is the volume at 2 minutes? Okay, so the question is, what is the volume of t? And specifically, we want to know what is the volume at 2. Well, how do I get volume? Well, what I have is dv dt, and so I need to go backward to find the volume. So what I'm going to do is I'm going to find the antiderivative of this guy with respect to t. That is the volume, okay, as a function of time. So this, hang on one second, is equal to, so we need to find the antiderivative of this guy. So let's go ahead and work this guy. So this is equal to, well, you know what? I'll use our rules so you can see what's going on here. This is 3 integral of t dt plus the integral of t plus 1 to the negative 1 dt. This one's going to be the easiest one to do. This is 3t squared over t, excuse me, over 2. Okay. This one right here, a little bit harder to do. So we need to see if we can find a, did I write this down right? Oh, sorry, this is negative 2. Okay, so we add 1 to the power. So that'll be t plus 1 to the negative 1, and then we divide that by negative 1, but we need to make sure that we multiply, that we've divided, I should say, by the derivative of the inside, which is just 1, so we're good there. Plus we need some constant of integration, so that's v of t. So now let's go ahead and simplify this. So this is 3t squared over 2 minus 1 over t plus 1 plus the constant. Now the constant, I'm going to tell you, is 0. So let's think about why this guy is 0. Well, it says that the tub, this thing right here, is empty at time 0. So that means the velocity, or the volume at 0 is equal to 3 times 0 squared over, over 2. Can't be over 0, right? Over 2 minus 1 over 0 plus 1 plus c, and the volume at 0 is 0. So 0 has to be equal to, this is 0 minus, well, let's see here. We're going to have to make a correction here. Minus 1 plus c. Okay, so if we do the computation there, then that means that our c value has to be, I was wrong, the c value has to be positive 1 to make this guy balance out. So c is equal to 1. Okay, so what do we have for a volume function? Well, volume as a function of time is equal to 3t squared over 2 minus 1 over t plus 1 plus our constant of 1. And now the question that they asked is, what is the volume at time 2? Well, that's 3 times 2 squared over 2 minus 1 over 2 plus 1 plus 1. So let's go ahead and reduce this. This is 4 divided by 2, which is 2 times 3 is 6, minus 1/3 plus 1. So this is 7 minus 1/3, which is 6 and 2/3. And we write that as 6.6 repeating. And of course, our volume here is going to be in gallons. Okay. So we've got 6 and 2/3, or 6.6 gallons, will be in this tub. That's this right here. This is 6.6 repeating gallons at time 2.